Okay guys, here is a video explanation for the review problems for chapter 2. So this is question number 6. A 75 gram sample of a white powder is chemically broken down into 29.86 grams of copper, 15.06 grams of sulfur, and an unknown amount of oxygen gas. So we want to know two things. How much oxygen gas was made, and we want to know to make 11.2 grams of a white powder with no leftovers, how much of our basic ingredients would we need? So from the reading, I pulled out the important information. So this is how much we started with. This is what we broke it down into. And we see we have a question mark here because we don't know how much oxygen gas was created. But we should be able to figure that out quite easily because we know the law of conservation of mass. What I start with has to equal what I end with. My scale is going to stay unchanged. So all I have to do is subtract away all of what I know from what I started with, and I'm left, when I take away the 29.86 and when I subtract away the 15.06, I'm left with 30.0 grams of oxygen. That has to be there because these numbers right here have to add up to be 75 because of my law of conservation of mass. I know I have no leftovers, so all that missing weight has to be from the oxygen. Okay, so now I have answered question A. So now I want to know if I make this 11.2 grams, what am I going to need? How much of each of these ingredients am I going to need to make this new weight? So if I look at this, I'm making less, right? So that means I'm going to need less of all of these. So that's a check mark, something you can think about as you are answering this problem. When you get an answer, you can kind of look at it and reason if it's correct or not, right? So I'm going to look at my ratios though. So remember, we want to know part to whole. Our law of fixed proportion says that if it's the same substance, my ratio of ingredients is going to be the same regardless of how much of the substance I'm making. So we've got to look specifically at our oxygen because that's the one that we want to know. So if I look here, I am comparing my part to my whole. Oxygen is 30.08 grams, and my whole compound is 75 grams. So when I do that ratio, I get that my compound is 0.4 or 40% oxygen. So what is 40% of 11.2? Because if this amount is 40% oxygen, it's going to give me 30.08 grams. If this amount is the same substance, 40% of its mass is going to be attributed to the oxygen. So I can multiply 11.2 by 40% or 0.4, and I get 4.48 grams of oxygen. So we can go on because the question asks us for more. So I can do the same percentage for my copper, 29.86 grams of copper to 75 grams of my substance. These numbers, remember, are my part to my whole, and they come from my original information from the problem. And if we do that, we get that it is 39.8% copper. So 39.8% of 11.2 gives us 4.46 grams of copper. Right? Now, to get the last one, to get my sulfur, because that's my other ingredient, I could go through with this ratio, or since I know 4.46, 4.48, I can subtract both of those away from my 11.2. I could just do it like I did up here. Since I know two of my masses, I can solve for my last one. Or we could do the ratio too. So I'll leave you to be able to figure that one out because I didn't write it down. Okay, so moving on. That was question number 6. This was straight up law of conservation of mass to figure out the mass of oxygen, and it was our law of fixed proportions to get us our proportion of each ingredient and make a new amount or a lesser amount in this instance of our product. Okay, so not question number 13. We want question number 7. Question number 7 is very similar. So if we look right here, a chemist makes 86.94 grams of a black powder by reacting 54.94 grams of manganese with 32 grams of oxygen. If a student breaks down 144.9 grams of powder, what mass of manganese and what mass of oxygen will be made? So same thing, I pull out the important information, 86.94 and 54.94. It's important to know that there are 4 significant digits in all of my measurements here, so I'm going to need to conserve that as I work through my problem. So if I make 144.9 grams, how much manganese am I going to need and how much oxygen am I going to need? This problem is very similar to the last one that we worked. Hopefully by now you know that to solve this, we're going to need our ratios. We're going to look at the part to the whole for this recipe. Those percentages are going to be the same as this one because it's the same substance. And we are going to be able to do our math from there. So let's look at our ratio. We are going to do first our manganese. So our part that is attributed to manganese is 54.94. Our whole amount of product is 86.94. So if I divide the top by the bottom, I get 0.63, which is equivalent to 63.19%. If I do the same for my other ingredient, I get 32 over 86.94, or 36.81%. If I add up these, it should be 100. That's a way you can check yourself to make sure your work is correct. We only had 2 ingredients, so these percentages have to add up to 100, so we know we're on the right track. Now, what do I do with these 2 numbers over here? I'm going to apply these percentages to my 144.9, because that 144.9 is going to be 63.19% manganese and 36.81% oxygen. So all I have to do is multiply. So my new substance will include 91.56 grams of manganese and 53.34 grams of oxygen. I know that that's correct because if I add them up, it gives me 144.90. You don't have to have the 0 in this one. You can just do 144.9. That's 4 significant digits, which it matches our initial measurements that we started with. Okay, so moving on to question number 8. So number 8 and 9 are very similar. So we'll just look at it this way. So in an experiment, a chemist reacts 7.85 grams of manganese with 2.29 grams of oxygen to make 10.14 grams of a powder. We want to know if it's the same powder as in powder 7. So to know if it's the same powder, I pull out my important information. Those are my pieces and my whole weight. So if it's the same powder, it's going to have the same ratio. If it's a different powder, the ratios are not going to be the same. So we've got to compare our part to our whole. So for this one, I get that my powder is 77% manganese and 23% oxygen. Is that the same as what we got? No. Our other powder from powder 7 was 63% and 36%. That is not the same. This substance is a different gas. It's got a different amount of manganese to a different amount of oxygen. There are different ratios here. So it's not just MnO. It could be MnO2. Or if you look at our percentages here, it's got a lesser amount of oxygen. So this substance has less oxygen in it than this one. So it will be a smaller substance. It's kind of what it figures. So question number 9 is very similar. So it gives you that in another experiment, a chemist reacts 10 grams of manganese with 5.8 grams of oxygen to give us 15.8 grams. We want to know if it is the same powder. So obviously we're going to do our ratios again. So this one is 63% manganese and 37% oxygen. So 63%, 37%, 63%, rounds up to 37%, so it is in fact the same powder. For these problems, all you have to do is get the ratio, the part to the whole, to find the percentage of each ingredient and check to see if it's the same. If it's the same as some other problem or some other substance, it's the same substance. If you get different ratios, different substance. Okay, so those problems all deal with the law of conservation of mass and our law of definite proportions. Our next problem are going to deal with this law of multiple proportions. So let's look at problem number 12. So Problem number 12 gives us two substances. So we're told that a chemist takes two different compounds from the same two elements, tin and chlorine. So he's going to react them, and he gets, for the first one, 50 grams of tin and 29.87 grams of chlorine make 79.87 grams of product. And our second one is 50 grams of tin with 59.74 grams of chlorine to yield 109.74 grams of product. So just looking at this, up here, we've got the same amount of tin in each one, but our amounts of chlorine are different, right? Our amount of product is also different. If we add both of these up, we get this number. That's how it came to be. Right, so 50 plus 29.87, 79.87, 50 plus 59.74, 109.74. So we are going to do ratios for this one too, but our ratios are different. What are we comparing? We're comparing here our amount of chlorine. I want to know if this one, if my first gas has 2 atoms of chlorine for every 1 tin, I want to know down here how many chlorines do I have for every 10. Is it going to be more or is it going to be less? We know that this one up here has to be SnCl2 because the problem told us that. Our second one is SnCl with some amount. So do we have more or less chlorine? If I look up here, 29.87, 59.74, I see that I have more chlorine in my second one. So this number, when I get it down here, is going to be some multiple of this number. It's not going to be 2. It can't be 3. Or I guess it could be 3. It could be 4, whatever. So how do we figure that out? Our law of multiple proportions says that I can't have half a chlorine atom. So if this is 2 chlorine atoms, I can divide that in half, and that's the mass of 1 chlorine atom. So I've got to figure out how many chlorine atoms is equal to this amount. And I can do that by dividing this in half and then dividing this number by 1 chlorine, or I can actually make a ratio of both of my amounts of chlorine. And that's the method that I'm going to choose. So 59.74 divided by 29.87 gives me 2. So I have twice as much chlorine in the second one as I do the first one. But why did I decide to put the 59.74 on top? Right? Well, that's just a little bit of a reasoning, right? I know that this number that I'm solving for has to be a whole number. It has to be greater than 1. It can't be a decimal number. So I just did a little reasoning here. I want this number to be a whole number, so I know I've got to put the bigger one on top for it to be a whole number, right? So looking at this, now this number tells me that I have twice as much chlorine in the second one. So if I have 2 in the first one, twice that is going to be 4. So the 2 times 2 makes 4. So my chemical formula for this second compound is SnCl4. If I had done this and I had gotten like 3, right? Or if I had gotten 2/3, right? So that would tell me that this one was 2 and that one was 3. I wouldn't have gotten that from this because of the way I set it up. I put my big number on the top. It would have been 3/2. But anyway, so whenever you can simplify whatever you simplify this ratio to, the number on the top of the fraction matches the amount on the top of this fraction. We're just simplifying this ratio here. Really, it's 2/1, so that's telling us that the top one is twice whatever the bottom one is. Okay, cool. So the last one is problem 13, and it is very similar. So we've got 2 different compounds again, right? So we want to know, according to this problem, how much we should use to make a new gas with no leftovers. So we're given some information about our first gas. And we're told that our first gas here takes 10 grams of nitrogen to 11.42 grams of oxygen. That gets used up completely to make 21.42 grams of our first compound. Consider it NO, 1 nitrogen to 1 oxygen. So we want to know if I use 10 grams of nitrogen with another amount of oxygen. I want to make a different gas, so a different chemical formula, a different ratio, but I want to use it all up. right? Am I going to need to use 20.5, 22.84, or 35.12? So for this one, same as last time, we are going to look at our ratios. Which one of these amounts gives us a whole number ratio or some derivative of our first amount? So I've got to come up with ratios that compare each of these amounts to my initial one. I want to find the ratio that gives me the best whole number, or the closest thing to a whole number. So I have all of my ratios here. The 20.5 over 11.4, 22.84 over 11.4, or the 35.12 over 11.4. So if I do those, simplify those ratios, this one gives me 1.8, this one gives me 2, this one gives me 3.1. I am going to pick the one that is the closest thing to a whole number, and bam, this one right here in the middle says that this number is twice exactly as much as my 11.4. It will be what will generate me absolutely no leftovers, so I'm going to use it. We can also infer from this the chemical formula of that new gas. So this tells me that I have twice as much oxygen in this one. So instead of it being NO up here, if this is 1 oxygen, my second one is 2 oxygen. So that means that the chemical formula for our second gas would have been NO2, or nitrogen dioxide. Okay? Hopefully this explanation helped you guys, gave you another example of the problems that you could expect to do on your test. But basically, the key word here for all of these is ratios. You've got to look at what you're comparing and what that comparison is telling you about our situation here. Okay? Good luck, guys.